Hello students, without wasting any time, let's get started. So we have the question. This question is MVVI for Bihar board as well as CBSE and in other state boards. Okay, and as we all know that our boards are going to held from 1st of February, so we have to be prepared, and that's why you should do this question because this is often asked. Okay, now we are given that in question torque, okay, torque acting on electric dipole when placed in uniform electric field, uniform external electric field. Okay, so now this word uniform is much more important in this derivation, because in this whole derivation this word is much more important, because this is applicable only for uniform electric field. Okay sir, now we are leaving this section. 1 minute. We are leaving this section to whatever we will assume we will write here. Okay, 1 2, let's say 7 lines. 1 2 3 4 5 6 7 8. We have used this. Now the figure will be like this. Okay, from here we will make figure. This is our, let's say this is our uniform external electric field. Okay, this is our uniform external electric field. We have successfully drawn this. This is our uniform external electric field. Okay, now let's say we have a dipole like this. Let's say this is our dipole. This is minus q and this is plus q. We will write here, this is minus q and this is plus q. If it is charged, then there will be definite that it will have mass and it will also have mass, because we have studied that mass can be without charge, but charge will definitely have the mass, right? So it will also have mass, it will also have mass. Now on positive charge, we know that force acting on positive charge is along electric field. Okay, so let's say force is acting QE, and on negative charge is opposite to electric field. This is, let's say, QE, right? My pen is not so good, that's why. Now we know that, and let's say with electric field it is making an angle theta. This is the center of dipole O, and from electric field it is making an angle theta. Okay, this is our angle theta, right? Now this is, since this is center of dipole, that's why if this distance is d, then this will also be d, and this force and this force are opposite to each other. That's why they will cancel each other, because uniform external electric field is applied here. That's why force, net force will be always 0. So we will write here F net is always 0 for uniform. Mind it, uniform external electric field, uniform, always. This will be always. But what about torque, sir? You will say that, what about torque, sir? We haven't studied it. So I think you have lost your 11th class, but don't worry, you will be know everything here. Okay, torque will be about, if these are positive, I mean same magnitude and are opposite to each other, then this torque will rotate along this center of mass, and this center of mass is O. That's why it will rotate. You don't think that this force will rotate this in this direction, and this force will rotate this in direction. Both are in clockwise, since it will be rotating like this, like this, like this, always like this, like this, like this. It will rotate, right? If it will rotate, then there will be torque, as we know that. Yeah. Now, so here tau 1 will be equals to net tau. Here net tau will be equals to tau 1 plus tau 2. Okay, and tau 1 is this is our tau 1, which is rotating this in this direction, clockwise. Okay, tau 1, and this is our tau 2. This is also in clockwise direction. Okay, sir. And as we all know that torque equals to force into perpendicular distance. Okay, force is Q into D E, and perpendicular distance between what? You will say that perpendicular distance between what? Between force and axis of rotation. Perpendicular distance between force and axis of rotation. This is our axis of rotation. But what is this perpendicular distance? No, sir, this is not the perpendicular distance. This is not the perpendicular distance. Now we will draw the perpendicular distance. Let's say this is our perpendicular distance from here. Okay, this is our perpendicular distance. If this is theta, then this will be sin theta, and this will be cos. This will be cos theta, and this will be sin theta. So this is d distance, d cos theta, and d sin theta. This will be d sin theta. And if this is theta, then this will also be theta here, right? Here this will also be theta along electric field. With electric field, it will make also theta. So this is theta, let's say. This is our electric field. Okay, we will break the components, and hence this is theta, this is theta. This will also be length, perpendicular length for this q2 minus q will also be d sin theta, d sin theta. Now we have perpendicular distance, everything we have got to know. Now whatever we have let, we should write here. So we have let an electric dipole having charge minus q and plus q, minus q and plus q are placed at a distance 2d, d plus d, 2d are placed at a distance 2d in external electric field, placed at a distance 2d in external electric field, Also, this angle we have considered theta. Also, angle between electric field and electric dipole moment from minus to plus. डायरेक्शन होता है ना इलेक्ट्रिक डाइपोल मोमेंट का, माइनस से प्लस. द डायरेक्शन ऑफ इलेक्ट्रिक डाइपोल इज फ्रॉम minus to plus. So this will be direction of electric dipole moment. So this will be angle between electric dipole moment and electric field. So angle between electric dipole moment and electric field, okay, is theta. We have considered this. Now we have to derive value of torque, on electric dipole. Okay, before proceeding this video, before the students, please pause the video to note it down. Please pause the video to note it down. And as we know, this tau 1 is clockwise, is in clockwise direction. This is in clockwise, this is in clockwise too. This is in clockwise direction. This is also in clockwise direction. Okay. We will write PTO in exams too, so that they can know that we have to turn here the page. Now, one minute, students. Okay, now what we have done here, see, torque on plus q charge is tau 1 and torque on minus q charge is tau 2. To get total torque, we have to add this because both are in same direction. Yes, so torque on plus q charge equals to tau 1, and we know that torque is equals to force into perpendicular distance, and perpendicular distance is between what? Between force and axis of rotation. You can write this line: perpendicular distance between force and axis of rotation. Axis of rotation. Axis of rotation. Force in between and axis of rotation. So it will be force. What we have? Force. We have force q into e and perpendicular distance d sine theta. So we will write this here: tau 1 equals to q e into d sine theta. Okay, we have this. Now, torque on minus q charge is tau 2, as we have done here. We have done here, na? Torque on minus q charge is tau 2. It can be equals to force into perpendicular distance, right? And it will be force, we have q into e into perpendicular distance, we have also d sine theta here. It will also be qe into d sine theta. Okay, sir. Now, total torque on dipole system, since this is vector quantity, tau equals to tau 1 plus tau 2. Okay, it is force into perpendicular distance plus force into perpendicular distance. It is q into me e into me d sine theta, plus it is also qe d sine theta. It can be written as, and we have this clockwise. Force tau 1 was clockwise and tau 2 was also clockwise. Yes, it can be written as 2qe d sine theta. Now we will do some jugaadbazi. What? Some jugaadbazi. Q into me 2d equals to p, right? ये अलग अलग है क्वांटिटीज. q into 2d p e sin theta tau, we have get tau equals to p e sin theta. Okay, we have get tau net equals to PE sine theta, where theta is angle between P vector and electric field vector. Here this is electric dipole moment is from minus q to plus q. This will be direction of electric dipole moment, and this is the direction of electric field. P and E, between P and E we have theta. Now it can be written in two ways. First is P vector cross E vector, we can write this, or second is E vector cross P vector. Now P cross E, if we do P cross E, okay, P cross E, this is our P vector, this is our E vector. If we did P cross E, this is in clockwise direction, and if we did P vector, this is P vector, this is E vector. If we did E cross B, this will be in anti-clockwise direction. So since it is clockwise plus clockwise will also give us clockwise direction, right? So this will be the right. So overall we can write here what? We can write here that since tau net equals to PE sine theta, therefore tau equals to P cross E, cross product. Okay, now I will say that you guys please learn this, please. This is much more important. Now question arises that when will be torque maximum? When will be our torque maximum? The question arises that when is this torque maximum? We know that torque equals to PE sine theta. To maximize the torque, we have to maximize the sine theta. If our tau is maximum, torque is maximum, therefore sine theta should be maximum, and which can be on +1 and -1. Therefore theta should be equals to +1 when on 90 degree and -1 on 270 degree, right? We will discuss here. Let's say this is our electric field. This is our electric field. If this is our dipole, here minus q, here plus q, this is center of dipole, this is D, this is D, and if this is making angle 90 degree with electric field vector, and from minus to plus our direction of P will be here, this is making 90 degree, so this will be the maximum case. And second one, what? This is minus q, this is plus q, we have made a dipole, direction of electric dipole moment this, and this is making angle theta what? This is our 270 degree. This will be the case for torque to be maximum. So torque is maximum on when theta is 90 degree or 270 degree. Mind it, read it, learn it. I don't know how, I have explained this, but I don't know how you have to learn this. Second question is that when it is this torque minimum or 0? Second question arises like this. When before that, students, please pause the video to note it down. Now we will proceed here. When is this torque minimum or 0? So we know that F net is always 0 when uniform external electric field is applied, F net will always be 0, but torque may be or may not be 0. Okay, torque may or may not be 0. So I don't know, tau is equals to PE, torque equals to PE sin theta, and to be torque maximum, our sin theta should be minimum. Our sin, minimum it will be. Our sin theta should be minimum, and which is at 0 degree. Sin theta should be minimum, which can be equals to 0, and then theta should be equals to 0 degree or 180 degree, which is also known as pi radian. Okay, so we will write here, when students, before that students, please pause the video to note it down. Now we will proceed here. When electric dipole is placed in uniform external electric field, then force on dipole is always 0. Okay, but torque on any dipole is 0 at only two positions. First, when electric dipole moment is along electric field, that means theta equals to 0 degree, and second, electric field P is opposite to E vector, that implies theta equals to 180 degree. Okay, so overall we can say that at 0 degree and 180 degree, dipole is in equilibrium position. We have written this. Now we will discuss the both cases. First case is at 0 degree, what will happen? Right, 0 degree. This is our external electric field. This is our external electric field. This is our external electric field, and our dipole 1 2 3 4 5 6 1 2 3 4 5 6. Let's say this is our external electric field. This is our minus q. This is our plus q. Okay, now we can say that here force acting on plus q will be here and minus q will be here. Okay, this will balance out, right? This will balance out. Now we'll do some experiment. If we slightly displace this, if we slightly displaced this dipole, let's say we displaced this dipole, this is our plus q, this is our minus q, you don't think that this will come in electric field, direction, because plus q will attract this in will try to align this in direction. All the story that we have studied here is here. Electric field always tries to align the dipole along its own direction. All the story is dependent on this. This line is much more important. You don't think that electric field will try to align this in direction, and if we slightly displace, then this will retard in this direction, and again this will be in this direction. So this is in stable equilibrium, as we have studied in class 11. One is stable equilibrium, second is unstable equilibrium, and third is neutral equilibrium. So this is the case of stable equilibrium. If we slightly displaced this, okay, pause the video to note it down. Now we will discuss the case of at 180 degree what will happen. 180 degree, okay. This is our electric field, uniform electric field. We have kept this dipole in this direction, minus q plus q. Force on minus q will be, this is our dipole, force on minus q will be by electric field. This is electric field, will be away from electric field, this will be towards electric field. We are pushing this like this, and if we slightly look here students, if we slightly displaced this dipole, there will be a interesting thing. We displaced this dipole, let's say this is plus q, this is minus q, okay. So it will be try to align in electric field direction. It will get more. If we slightly displace this, they will turn it back, and what will happen? It will come in this situation. This plus q will come here, and this minus q will go there. You don't think this will happen? Yes, this will happen. It will align, and this will be turned, plus q in this side and minus q in this side, okay. This is the case of unstable equilibrium. And one more interesting thing, if we slightly displaced unstable equilibrium, slightly displaced this unstable equilibrium, then we can make this stable equilibrium, because electric field always try to align the dipole along its own direction. Pause the video to note it down. Okay, bye students. We are meeting in another. See you in the another video of important derivation or important questions. Bye bye. See you. Take care students till then, and keep learning, keep growing.